Yeah, hello and welcome to this overview of MochaImport Plus for Nuke. My name is Matthias and I want to go with you through all these different functions that MochaImport Plus has to offer, such that you learn what you can do with Mocha tracking data inside of Nuke with the help of MochaImport Plus. I want to start with a corner pin plus with lens distortion. This is a corner pin that also supports lens distortion as said by its name. And as an example, I want to use this clip here from Hollywood Camera Works. So you can see here is a thing, and you can download it if you like from Hollywood Camera Work from this particular URL. So thanks at this point to Hollywood Camera Work for providing this clip. And here I have the clip inside of Nuke, and I also have here a grid that I want to corner pin on top of it. And for this, I already opened the track in Mocha, the clip in Mocha, and I tracked it. So you can see here it follows the track I did before follows this nicely. And all you need to do is to make sure this surface rectangle, this blue thing here, this is what you can turn on and off here, is nicely aligned with your plate, with the thing where you want to insert your corner pin, like this. And here you can also verify again that the track looks good and it follows our plate quite nicely. You will notice that here these edges are not perfectly straight, they are curved a bit. This is because of the lens distortion. And what I did for this before, I went here to the lens module and did a lens analysis. There are other tutorials from Imaginary Systems that show this process in more detail. But this is an optional thing, really. You can do corner pin with lens distortion or without. And let's first start with the easy way to do it without lens distortion. We go to our track tab, and after we did this track, we say export tracking data, choose from the formats Nuke corner pin, and say copy to clipboard. Now we go to Nuke, go here in our menu and choose the corner pin with lens distortion. And this has three inputs. One of them is the source. This is what we want to connect to this grid because we want to corner pin the grid. And then we have a background, and we corner pin or we connect this background to our background footage. And then we have the distortion map, which is for lens distortion, which we're going to look at later. If I preview this, you can see currently nothing. And if we say merge background, you can see our background. What we first need to do now is to insert our tracking data. And we do this by saying copy from clipboard. Remember, we copied the Mocha tracking data into the clipboard before. And now you can see we have here our grid, and our grid nicely moves with our track. And if we now click on merge background, you can see the background is nicely inserted behind, and it nicely follows the track. This is the basic corner pinning without any lens distortion. But you can see a little problem if we look closely here. You can see this corner is perfectly fine, this corner is perfectly fine, but here in the middle it doesn't fit. And this is because the grid is perfectly straight, whereas the green background here is actually not perfectly straight because of the lens distortion. And so if we want to also use lens distortion, what we need to go is in Mocha Pro, we go to the lens module. And after you did your lens calibration stuff here, you go to export lens data, choose in the options a distortion map clip. And here it's important to make sure it's set to distort, and then you save this thing. Then you get an image. I did this already before, and I imported this image here into Nuke. So this is a distortion map clip. And all I need to do is connect this to our footage. And now you can see our corners or our grid here is now curved in the same way as the green background, but the corner points do not fit anymore 100% accurately. And this is because when you use lens data, and you go to your track and export your tracking data, it is important that you enable this remove lens distortion. So when you use lens distortion clips, then enable this here before you copy your data. So I copy this to clipboard, go to Nuke, And now by clicking again from clipboard in our corner pin node, we override the old data, and you can see now it fits again perfectly. And also here, the curved lens distortion from the background is perfectly applied directly here to our grid. And everything moves nicely with it now. And obviously, instead of a grid, you could insert here a picture, a video clip, whatever you like. Let me quickly take a look here at these advanced options of the corner pin. You have here a time offset. This is when your tracking data doesn't start at the first frame, but at some other frames. You can change this here. This merge background turns our background on and off. Now we have only the foreground, and now we have the background in here. It's important when you use such a distortion map that you always provide a background. Even if you want to manually composite in the or merge in the background later, then it's better to turn this here off, but still leave the background connected if you use a distortion map clip, because the background size is needed to measure how to apply this distortion map clip here correctly. Now, therefore, always provide this background, and if you don't want it, turn it off here. Then we have for the corner pin, the basic corner pin options that you also have with the normal corner pin that comes built into NUKE. You can choose here filtering. You also have motion blur options to make this blur here, so I can crank this up. And here, obviously, in this clip, not much movement is happening, but you can still see some blur here around the edges. Maybe we can also increase our shutter. And now you start seeing some more motion blur going on here. Finally, also for the lens distortion, you can separately choose your filtering from the filtering here. This is just the details of these image processings done by NUKE here. Okay, the next thing I want to show you are the stabilized views of MochaImport Plus. If you know MochaImport Plus for After Effects, this is the same as stabilized pre-comps in After Effects. Here in this node-based setting, we call it stabilized view, and it's even a little bit more powerful since it also supports lens distortion data from Mocha. I want to explain you these stabilized views here with the help of this example clip. You can see we have here this camera movement, and I want to modify here a little bit this road that you can see here on the right hand side, this part. And for this I already tracked this clip in Mocha Pro. So I've selected this region here and I tracked it, and it sticks on quite nicely. And also I've set already a corner pin surface. So if I select this and enable here the surface, you can see this is our surface, and if I do it this size, it nicely follows our ramp, but I do it more, I make it a bit wider, because it should always have to look good, approximately the same aspect ratio as our original footage. You can see this clip here is wider than high, so I also choose this blue surface region here to be a little bit wider than high, to have roughly 60:9. It doesn't matter exactly, but roughly this format. Then I go to export tracking data, choose NUKE corner pin and copy to clipboard. And then inside of NUKE, I select my footage clip and go to MochaImport Plus and say stabilized view plus. This creates this entire rig here. And the first thing you need to do is go to the start stabilized node and paste your tracking data from clipboard. Obviously, you can also do it from file. And then if we take a look at this stabilized view at this node or this node here, what we can see is a new perspective on our clip where we look exactly at this road that we've tracked. And you can see that the road is not moving anymore in this perspective. Everything around it is moving. So what you're seeing here is the entire region that you had in your blue surface rectangle. Everything around it is moving, and the part that we tracked itself is perfectly static. Now if we go to the end stabilized and take a look at this node here, then you can see exactly the same region that we've seen in the stabilized view here, but you can see it's moving again. And it's moving exactly as the original footage, because if you compare this end stabilized with this original footage here, let me put this here on 2. this here on 2, and this here on 1. If I toggle between the two, you can see they fit perfectly, yeah, seamlessly. And this means also we can now take this and stabilized here and merge it over our background. And if you take a look at this final result, it currently looks as if nothing has changed. Yeah, it's like the original footage, but the great thing is we can now go inside the stabilized view and do arbitrary manipulations here. So let's take a look at this stabilized view node here, and let's do, for example, some painting. Yeah, so I just create a normal RotoPaint node. You don't need the RotoPaint Plus. This is a feature from MochaImport that I will show in a minute, but for now let's go with a normal RotoPaint node and drag it in here. And now let's say we want to clone stamp to remove some of these issues here. Let's say we want to remove this dirt element here. And for this, I just let me just quickly adjust here the settings of this clone stamp. Make the brush a little bit bigger. Make sure that we paint on all frames. And now with the Alt selected, I click and drag. And now I start copying. Yeah, this is a normal painting procedure that you might know from NUKE, like this. And then let me choose another region to copy from, like this, and paint this out too. And now if we play through our sequence, obviously this change is applied to each frame. Yeah? And now at the very end, you can see here this black hole occurs because at that point we are copying from material that is outside of our view. So maybe in this particular case, it's not so clever to copy something from the bottom. But instead, let me again change it and say we copy something here a little bit from here maybe. Whoops. Exactly the opposite what I wanted, like this. But you get the general idea. We can start painting here inside of this view, and all changes we do are now automatically applied also to our final result here. So if we take a look at this, and here is the region that we actually changed. You can see in this stabilized setting, also the element that we painted on has been removed. So again, compare. This here was our original, and this here is a painted one. And here's our painted out element. And now we can do also arbitrary other modifications inside our our stabilized view. So we can, for example, go here. You could load, for example, you could export this here as an image, manipulate the image in Photoshop and bring it back in. Or let's say we just insert some text here. Yeah? So I create another new node, text, and call this stabilized view. And move it over here and actually embed it in our tree. So I merge this on top or after our roto. And now this is what it's looking like. Yeah, I've just placed this text here on our street. And if we go back to our final composition, you can see the text is here, right on, like glued on this street here. And you can see here it's now nicely moving with our track. So the general idea of the stabilized view is really create this stabilized setting and work in the stabilized setting in whatever way you want. So you can put arbitrary nodes inside here, create new elements, paint on stuff, do whatever you like, and all changes are automatically brought back by the end stabilized here to our original perspective. Again, here you can see just this part that is contributed by the stabilized view, and then you can finally merge it over our background to get the final result here. There's one little quality issue, so to speak, with this approach, and this is all the pixels in the stabilized view. So all these pixels here are first undistorted, are stabilized to get the stabilized view, and then they are transformed a second time again to be brought back into this perspective. Yeah, this means each pixel here has been processed twice. First stabilizing, then undoing stabilization, essentially. And to improve or to get rid of this tiny bit of quality loss, what you can say is you can check in the end stabilized node here, you can say only render modified pixels with a certain softness. And if we pre-multiply our alpha channel, you can see what this means. Now from this entire view, this node only renders these pixels that we've actually modified. So these pixels that we've painted on, and you can see they nicely animate with our track, and these pixels where our text moves. And this means all other points, if you merge them here, yeah, with this one, now all other pixels come from our original background. So this means this process of going to the stabilized view and going back now only happens for these pixels that you actually modified. And this is determined automatically by this rig if you simply enable here this only render modified pixels. And with the softness you can increase it. You can see the more you increase it, the more pixels it grabs around the area that you modified, such that you can blend this in nicely. This is just a normal pre-mult of the alpha channel, such that you can actually see the changes of your alpha channels happening. Then again, we have here the standard corner pin features for motion blur and the filtering of the corner pin that goes from this stabilized view back to your original perspective. Yeah, this is happening here in this node. And we have also a filter for the lens distortion, because all of this also works with lens distortion. I'm going to show you this in a second. If we go to the start stabilized node, you can see we have here the settings for the loading the tracking data, what you already have seen. If you do this, after that here you have your tracking data. So if you want to modify it, you have it here as numbers, so to speak. And you have this corner pin time offset, which means if your tracking data in your Mocha project starts at a different frame than actually in your NUKE project here, you can enter here an offset to fix this. And also here in the start stabilized, you have this corner pin filter and you have this lens distortion filter. Yeah, this is not identical to the settings here in the end stabilized node. Again, here start stabilized has corner pin and has lens distortion filter, and also end stabilized has lens distortion filter and has corner pin filter and also some motion blur options. The difference between the two is that this here is corner pin and lens distortion when you go inside the stabilized view. Yeah, this is for start stabilized, and this here corner pin and lens distortion is when you go out of the stabilized view. And I think this is really I think you rarely need to change these filters, but if so, it's important to understand which filter is for what. And finally here, when you go back from the stabilized view to your end stabilized, you have these motion blur settings. This means if you enable here only render modified pixels, and then you can even after that apply some motion blur. I mean, here everything is so slow, you won't see any slow movement, you won't see any motion blur. But if you have faster moving elements, just increase your motion blur here and you will get even automatically motion blur on these elements that you modified here. So now I want to quickly go back to this clip that you've seen before for this corner pin with lens distortion, because I also want to show you how this stabilized view is working with lens distortion. So let's first do exactly the same as for the other example. We go to the track tab, and after we've set here this corner pin surface, and you note I've now set it a little bit larger than this green element itself to have some context, because it's always nice in a stabilized view to have some context. I go to export tracking data and say copy to clipboard. Now I can again go to NUKE. I have my footage here already, and then I go to MochaImport plus stabilized view. We get our stabilized view. I go to the start stabilized and say from clipboard. And now you can see we have here as a final result. Now we have here our corner pin region nicely moving with our original perspective. And I can now take a look here inside the stabilized view at this node here. And here you can see we have our stabilized setting where this green card is not moving anymore at all, perfectly stabilized, and we can start manipulating it and everything around it moves again. And obviously to get our final image we need to take this end stabilized here and merge it. We merge it over our original source clip. This is something you always need to do to merge it. And then finally we have here our original. And I can now do again arbitrary modifications inside the stabilized view. For now, let's say we want to have here some grid node, and I want to merge this grid inside of here, and maybe let me increase the size of the grid such that you can see it a bit better. And now you can see in our final clip it's looking like this. The grid is nicely moving with our green element here. But if we take a look at the stabilized precomp here, you can see inside the precomp it's perfectly static and nice. But you can also see we have some problem here. Here this edge of the grid is perfectly straight, and the border of the green element here is not perfectly straight. Yeah, it's a little bit curved, and this is again our lens distortion issue. So how do these stabilized views work with lens distortion? Well, essentially it's almost the same as for the corner pin with lens distortion. You first need to make sure you export your lens data after you have configured your lens calibration here inside of Mocha. If you go to export lens data for the stabilized view, it's important that you do both the undistort and the distort. So first select undistort and then click save, with here distortion map clip selected to get an undistortion map, and then open the export a second time. This time choose distort and also choose save to create both an undistort and a distort map, because you will need both in this particular case. I have exported these files already, therefore I can just click cancel and go to NUKE and load these files here. So I first use a read node and choose here our undistortion, open. And this undistortion is actually necessary for the start stabilized, so I move it close to here. And then we also need another read node for our distortion map, open. And the distortion map is like, you want to undistort to get a stabilized view with straight edges, and then you want to reintroduce it when you go back to your original perspective. So I put this one here close to the end stabilized, where I need to go back and reintroduce these curved lines of the lens distortion. And then all I need to do is really connect the undistortion map here. And now you can see these lines become perfectly straight, the green edges. Again, I undistort, and you can see there's a subtle curving in this green compared to the straight white. Here maybe it's in particular obvious. Curved green line versus straight white line. If I connect this here as undistortion map, you can see they are more parallel now. Here also. And then I need to undo this. Otherwise our end perspective will not look good. And connect here the distortion map to reintroduce, so to curve this again when we go back to our original perspective. And if we go back here to our original perspective, you can see now with this one connected, here these lines are curved. And with this not selected, they are perfectly straight. But you can also see this doesn't really fit 100% here. So now with the curved, you can see in particular, if you look here at the arm, now it also fits again nicely. So in other words, make sure to always use both the undistortion and the distortion if you want to use lens distortion at all. And another very important thing, here you don't even notice a big difference, but in general, if you use lens distortion and you export your lens distortion data, not the lens distortion data, the tracking data, export tracking data, make sure to enable this remove lens distortion option. So this you need to use whenever you use lens distortion data with MochaImport Plus. So I copy this to the clipboard, go to NUKE, go to my start stabilized node here, and say again from clipboard to use this other data. And you can see everything slightly changed. Often there is not a big difference, but it makes a difference. So make sure whenever you have lens distortion data to make it look like this, to use the data where the lens distortion option is checked there. And yeah, now you can see the grid is curved here in the final result. You can do any kind of changes here and get back your lens distortion at the very end. But if we take a look here inside our pre-comp, you can see inside the pre-comp the grid is straight, and it's really easy to do here any arbitrary modifications, not just inserting grids, but doing paintings works there, inserting images, to whatever you like. I think a really powerful workflow with these stabilized views. The Tracker Plus, or also the Tracker Plus Old, is just a normal implementation of the tracker node from NUKE. You can see it here. A normal tracker node, but with this additional MochaImport Plus tab that allows you to load tracking data from Mocha. So to show you how this is working, I go to Mocha Pro, and I have again here my track, and I adjust this blue surface rectangle to only the area where I want to have my my points. So let's say we want to have 4 points, these 4 corners around this element here, and you can see it's nicely moving with our track. I go to export tracking data, say NUKE corner pin, and copy to clipboard. Now I can go back to NUKE, go to my tracker node and say from clipboard. And now this data is imported. And if I take a look at my clip, you can see we have with the tracker node, if you select the tracker, you can see these 4 points, and I can actually highlight any one of them. Yeah, we have here these 4 points, and they nicely follow our track, as you can see here. The same is also possible with the old tracker. So if I say here tracker old, this is as you can see here, the tracker that was used in NUKE 6. For whatever reason you need this one, you can also use it. Let me close this node here for a moment. So we have here our old tracker. Again, you have this MochaImport Plus tab and say from clipboard. And if we now go here, you can see we have our 4 track points that nicely move with our track, and that are exactly located at the 4 corners of the corner pin surface that you've set in Mocha. Apart from this MochaImport Plus tab, these tracker nodes are really fully functional, perfectly normal tracker nodes, and you can do anything with it that you can do with other tracker nodes inside of NUKE. Similar to the Tracker Plus node, also the RotoPaint Plus and Roto Plus nodes are exactly the same as normal RotoPaint and normal Roto nodes, except that they have the ability to also work with Mocha tracking data. So let's take a look at the RotoPaint. The Roto really works exactly the same way. So let's start with the RotoPaint for now. This is a normal RotoPaint node, but it has this MochaImport Plus tab here. And let's say we want to do some roto and some painting job on this layer or on this road here. And in Mocha, I have already tracked this, but I also have a second track for this road here on the left. Yeah. Here's the one track, here is the other track. And let's say we want to use both of them in our roto node. Yeah. So I first export the tracking data for the right one, and for these functions actually it doesn't matter at all how you set here this blue surface rectangle, it just matters what you tracked. We export the tracking data with NUKE corner pin selected, copy it to the clipboard and go back to NUKE. And in NUKE you can apply it to the root layer here, but this means everything on this paint or roto node moves with this track, and we want to make it a little bit more structured. So we enter here something and call a new layer and say right ramp. And then I again select the root, again click plus and say we have another left ramp. And we have currently tracked we have in clipboard currently the tracking data for this right ramp. So I say apply to layer right ramp and say from clipboard. Now the tracking data is applied to this right ramp. And now we can go back to Mocha Pro and select this left ramp here. Go export tracking data, NUKE corner pin, copy to clipboard, go back to Nuke and say now we want to import tracking data in the left ramp from clipboard, and now we have applied different tracking data here. And now the great thing is everything that we put in the right ramp will move with this one. So we can, for example, go here and say I want to create some mask around this, and it's in the right track, so it exactly moves with this element. And in the same way, we can also do, for example, some clone stamping or so. And for this, I connect here this as a background node, and I've configured my clone stamp already as I need it to, for example, paint out here these elements. And if we take a look at this node, now you can see this is painted out, and I can do some more painting here. And let's say, just for the fun of it, we duplicate this line here to the right. Do some arbitrary modifications, and you can see all these modifications now perfectly nicely move with our track. Now if we want to do some manipulations here on this left element, say painting out here this white spot or so, you can do this also. Just make sure that now you do this in the left ramp, because this is where we attach the second track. So I can just do here some rough painting, and also this, as you can see, now nicely works with our track. Okay, the next function we want to take a look at is the GridWarp Plus. This is again a normal GridWarp node, as with all these other plus nodes here, Tracker and RotoPaint and Transform 2, but with the ability to load Mocha tracking data. And what we want to do here in this clip, let me just take a look at it. You have this face here moving, and in this clip we just want to modify this ear here. We go at some point that we like, frame 5 in this example here, and add here some more lines. Let's say we need here one more line, and here, and here, and here, and also maybe here. And now let's say we do some very simple deformations, like let's say he should look here a little bit more fancy like this. Like this. I like it. And now obviously we haven't applied any tracking data yet, so we can see once the head moves out of this, it has no effect anymore. So what we can do is we go to Mocha Pro. I have tracked this ear here already, and you can see the track also nicely follows when the head is turning. And then I say export tracking data, copy to clipboard, and I go to Nuke. I go to the frame where I liked it as it is. This was frame 5. At frame 5, this grid here has the correct position. And then in this GridWarp node, I go to this new MochaImport Plus tab and say from clipboard. And now you can see when I move over in time, the grid starts moving with our face here. And you can see now, even if the head starts turning, now it is deforming in a pretty fancy way to ensure that this ear still looks good. So let's take a look at this without the annoying grid. And now you can see that it's looking pretty nice, and that this deformation nicely follows even when the head is turning. So pretty powerful thing here, since all the movement of the grid, not just position, scale or rotation, but really everything, including the shear and perspective data you have in Mocha, is applied here to this grid. If you're wondering what goes on behind the scenes, each GridWarp node has a transform tab, and in the transform tab we have here this extra matrix, and this is where all the Mocha tracking data is located. This is now keyframes. These blue elements here are the Mocha tracking data, and this means it's not like keyframed into this grid. You're still free to do keyframes on this yourself. So remember, we've set on frame 5 some keyframes to deform this grid, and now we could also say at frame 1 we want it to be like this. And now we have from frame 1 to frame 5 here such a nice transition, and still you can see the tracking data remains applied. Everything is moving, but your free to modify this grid at different points in time, keyframe it however you like. The movement of Mocha will always stay like behind that in the background. I think this is a great function to do any kind of beauty, retouch, manipulating faces, whatever you like here. Okay, the Transform Plus is also a normal transform node, but extended by MochaImport Plus in order to be able to handle Mocha tracking data. And it works as follows. So let's say we have here this background, and we have here this grid, and we want to move the grid, so we connect it to the transform and merge this in front of on top of our background. So the merge now looks like this, and currently obviously nothing is moving. Now we go to Mocha Pro. I have tracked here this ear, and as I export tracking data again, new corner pin as always for MochaImport Plus, copy to clipboard, go back to NUKE, and in my transform MochaImport Plus node I have now this additional MochaImport Plus tab, and say from clipboard. And now you can see it jumps in the middle of the area that you tracked, and it moves here with our head like this. And in general, I don't recommend using transform nodes because they are not as accurate as corner pins, for example, or as our stabilized views, or as actually all these others, Tracker, RotoPaint. If we directly use a GridWarp or a RotoPaint, this is much more accurate than trying to move roto shapes with a transform. And let me try to explain you why this is the case. Mocha can track different kinds of movements: translation, scale, rotation, shear, and perspective. And you don't get perspective with the transform. And if you usually create transforms with the help of a NUKE tracker, you don't even get shear. So in other words, if you use a transform node, use a MochaImport Plus transform because it can handle shear. And better don't use a transform, but use any of the other MochaImport Plus features because they can even handle perspective data. If you use a transform node, don't track with perspective because what you will get will throw away this perspective information. Actually, this is what technically will happen. Also, if you create it with a NUKE tracker, for example. I want to show you this to make it a little bit more clear. One thing that I find remarkable here about this method is when you see at this point, the head turns, and you can see also the grid starts deforming. Maybe this is even more visible if I put before that another transform where I move this grid more in the middle so that we can see what is going on here. Maybe let's move it like this. And now if you take a look at what is happening here, you can see it looks like it is actually turning to the side. Now let's compare this to a NUKE tracker. So let's say we use a Tracker Plus from MochaImport Plus because this is easy to load the same tracking data. So I say from clipboard, and now I have the same ear track inside of my tracker. And as it's a normal NUKE tracker, I can do something like saying, please create me a transform match move. Create. Now we have another transform here, and if we compare this transform to the transform from MochaImport Plus, this is a normal transform created from a tracker node. This is our MochaImport Plus transform. Let's take a look how this is looking like. So we also merge this one here in front of our background. And if we take a look at this merge, it is looking like this. It's following nicely our track, but now you can see when the head is turning, this grid makes no attempt to turn. It's rotating a bit, but it's not turning in perspective like in 3D. If you compare it to this one here, again the MochaImport Plus transform, it's turning in 3D. You can see here the head rotates, and it's like this grid is not 100% exactly following, but at least it makes an attempt to change in perspective, which is not happening with this grid here at all, which is like pure 2D scale, rotation, and position. And this is exactly the difference in Mocha Pro between having this shear or having a pure translation, scale, and rotation. So it makes a huge difference in accuracy and in usefulness. And you can also see this if you take a look at these nodes in a bit more detail. So if you take a look at the MochaImport Plus transform node, go to the transform tab, you can see we have keyframes on translation, rotation, scale, and on this skew, which makes this 3D-ish movement. And if you look the other transform node created by the tracker, you can see it has position, rotation, scale, no skew, and just modifies here also the center. So this is a big difference. You get the skew data if you create your transform nodes with MochaImport Plus, but again, still the perspective data, so still this part of the data here, the perspective data, you will never be able to get this in a transform node, and this is why I highly recommend, whenever possible, don't use transform nodes. Better use, if you do painting or rotoscoping, use the RotoPaint Roto Plus nodes. For beauty, use the GridWarp Plus nodes, and for other things, really use the stabilized view, which is really, really powerful, or the corner pin, because all of them support the full range of Mocha tracking data, including position, scale, rotation, shear, and also this perspective data. Functions of the MochaImport Plus that you've seen so far were just using planar tracking data, but Mocha Pro also has here this camera solver, and we also support this with MochaImport Plus for NUKE. So if you really want to do stuff in a 3D space, you need to solve your camera, and sometimes the Mocha camera solver is a good idea to get a track or camera solve. Here in this case, I have selected these three planes to track, the sign here and this pole and the background, because when you want a camera solve, you need more than one plane to track, and you can just select all of them and say, or make sure they are enabled here, click on solve, and then a camera track is calculated. And in this case, it has a solve quality of 97%, so pretty nice. And I can say export camera data. And then what you need to choose is FBX data for NUKE 6.3 something. Yeah, so this FBX for NUKE is really what you want to export. You save it. I don't do it because I have saved it already. Then you can go to NUKE. You can select the footage. And in MochaImport Plus, say full camera rig or camera and geo. Let's first start with the full camera rig. It asks you for this FBX file that you've exported. I open it, and now I get this entire rig here. If I take a look at it and play it back, you can see it consists of a scene and a camera and some other stuff going on. And if I take a look at my background renderer here, a scanline renderer, you can see I have here a point cloud of points that move with these tracks. Yeah, so you can see this even better if I brighten up here the background a bit, just for the purpose of the demonstration. Now you can see here this point cloud, and here's this point cloud, and here's this point cloud, and obviously they are matching pretty nice. So this means our camera track is really good, because of course, not these points are really moving. These points are perfectly static. They are this point cloud here, but the camera is moving and makes them look as if they would move with the scene here. If you wonder about more details about this camera rig here, I highly recommend you to take a look at the following tutorial at Imaginary Systems. So go to imaginarysystems.com to their video tabs, and then look for for tutorials about the 3D camera solver. And there's this great tutorial by Martin Brennand, 3D camera solver and NUKE. And in the second part of it, you will get more infos, because exactly this this is what happens when you are recording demos. And because here exactly this rig is explained in more detail, how it allows you to orient the camera and why it's useful in general. So pretty powerful. If you say, I have my own rig, I don't want you to create all these nodes and then I have to delete lots of them because this is doing too much for me, no problem. Let me delete this again. The other option you have is to say MochaImport Plus, just create a camera and a geo. You again load this FBX file. And now you have just these two nodes. So this is your point cloud from Mocha, and this is your camera that moves according to the track. And then you can construct everything around it manually. Okay, that's it for this summary of MochaImport Plus for NUKE. I hope you enjoyed it and really understood now why MochaImport flows could be interesting for your NUKE workflows.